So hello everyone. So our next talk is from Morten, and the talk is going to be about emulating Julia code evaluation. And Morten is going to talk about a package called CodeEvaluation.jl.
Cool. Audio is working. So yeah, basically I just want to talk a little bit about some housekeeping work I've been doing in the Documenter.jl package, which, if you're not familiar with Documenter.jl, it's the package that you can use to generate the documentation websites for Julia packages. The Julia manual, like a lot of Julia packages use it. The Julia manual is generated with it, and so on and so forth. And the aspect I want to focus on today is the parts where Documenter actually can take and evaluate arbitrary Julia code that the user provides in the documentation. So to explain what I mean by emulating Julia code evaluation, so Documenter has this feature which is, so in general, in a Documenter, the inputs are markdown files. And within a markdown file, what you can have is a special code block which you tag with an add example. Within the code block, you can have arbitrary Julia code, and the Documenter will find it and will actually evaluate the code for you. But the code does not end up in the sort of terminal or anything like that, or the output, I mean. It is actually able to capture all the output and splice it into the final product, like the HTML or the PDF document that it generates. So the question what I really want to answer is how does that actually work? What is worth noting is that Documenter is by no means the only package in the ecosystem that does something like this. There's a whole set of what I would call documentation generation, or document generation packages. So for example, Weave has this, which is for report generation, has the same thing. There's a code block and it will evaluate it. Same thing, Franklin, which is static site generator, can do it as well. So it's not specific to Documenter.jl at all. But okay, now let's imagine that you want to write this kind of program, Julia program, that will, has to evaluate arbitrary Julia code. So what are the sort of requirements? What do you have to think about? So first, you need to be able to parse and evaluate the Julia code. That's because the inputs will be from a markdown file or something. So after you have parsed those files, it's going to be just a string of bytes in your data structure or whatever you have. So to actually evaluate it, you first have to parse that, and then also somehow convince Julia to evaluate that within the same process that is already running your code, that is parsing the whole thing and building the whole document, right? So that's one. Second thing, this might not always be a requirement, but it is a requirement for Documenter, which is you want to have a clean environment for each separate sort of execution of code. That is because, if you imagine your for example, your documentation is probably going to be made up of multiple pages, and each of those pages is going to, might have a bunch of add example blocks. You don't want variables and stuff and function definitions and all that kind of stuff from one page to sort of leak over and interfere with the other page. So every time you evaluate one of those add example blocks, it needs to look as if it is within a clean main module, but there is only one main module in Julia. So how do you do that? We'll get to that. And last but not least, output capture. So we are evaluating arbitrary Julia code, which means that code will likely print stuff into the terminal, have logging macros, uses logging macros. Normally this stuff ends up in in the terminal or maybe in your CI logs or that kind of stuff. We also want to capture that. So that's the third thing you need to think about. The good thing is, Julia has all the basic building blocks to actually do all this very easily. The issue there is, it is just slightly non-trivial to get it all working correctly, which means, in my mind, it is worth having good abstractions and good interfaces at this level, and have a little bit of code reuse. So this is where we come to the actual packages that I put together. That do this, and so the motivation really comes from the sort of the Documenter use case, but I hope that they're also useful for the community, more broadly. Something I do want to mention here though, like all the ideas that I'm about to show you and like the implementation, a lot of that has been done by other people and like has existed in Documenter for a long time. So Michael Hatherley, I think, would be like the author of a lot of these ideas, and then a lot of people have sort of added bug fixes over time. So I just want to acknowledge all the work that others have done, and I basically just put a nice, like I've just made it a little bit prettier. That's my contribution here, so I just want to acknowledge that. All right, so going in reverse order. Output capture, how do you do that? You can use IOCapture.jl. Julia actually offers these functions called redirect std out stdr that allows you to take control of the standard output and the standard error streams in your Julia program. You can basically redirect all the standard output to a different stream or into a buffer or something like that. When it comes to the logging output, you can also use custom loggers for that. But as I said, like, it is actually slightly non-trivial to get that working. The naive implementation using like redirects std out will likely hang your program often because some buffer gets filled up and like everything hangs. So in IOCapture.jl, it's a pretty tiny package, but we figured out some of these edge cases. And so you can just do this, where you have this do block syntax, and any code that executes within the do block, any output from that code is going to get captured. And what you get back is a nice object where you can access like the return value and the captured output and so on and so forth. I do also want to mention there's an alternative package called suppressor.jl, which basically works the same way, does the same thing, has just a different sort of macro-based syntax. So do want to plug that as well. 2. For the clean main environments, what you can do is anonymous modules. So in Julia, you can actually construct an empty module using the module sort of function call. I don't know what it is technically. And then you can start evaluating into that. What requirement you have is, so if you want to make it look like main, you also have to do some additional tricks because like the module is gonna have a random name, and actually when you're evaluating into main, like in the REPL, like you get stuff like the ands variable gets set and that kind of stuff. So core eval by default doesn't do any of that for you. So the evaluate function in code evaluation sort of takes care of all of these things. And yeah, code evaluation in general offers you this interface where you can just construct the sandbox, which is this thin wrapper around the this anonymous module, and you can like have as many as you want, and they're all more or less independent. Something that is worth noting here is there are limitations to actually both of these things, so including the IOCapture. If your code is doing a lot of like stream, like mucks around with the streams a lot, then things may break. It's not perfect. It's a bit of a hack. Same thing here. Like if you're messing with the global state of Julia or something like that, that will leak over. So it's not perfect isolation of the environments, but it is good enough for sort of 99% of the use cases that say Documenter users see. So it works. Lastly, the way I've envisioned CodeEvaluation.jl right now is like there's going to be also a bunch of like higher level functions that can handle like different ways you might want to evaluate Julia code. So there are 2 things implemented in there right now, which are very much Documenter.jl use cases. In one case, you just take a bunch of Julia code and just evaluate it. The only other thing it does, it basically parses that string into the expression first, which is very easy to do in Julia. There is also a function that just parses strings into Julia expressions. So the other one is a little bit more sophisticated. It can actually emulate like a REPL session for you. And I imagine like there could be a whole library of these functions. So all in all, packages are up in the Julia Docs organization. So if you're interested, please do get in touch or check out how they're implemented. They're actually really tiny packages, so they should be very accessible for anyone who's interested in how they work. So yeah, that's all. Thank you.
Round of applause. It was a good talk. So in the interest of time, we have to proceed with the next speaker. But Morten will be here, and if you have questions, please approach.